Hello and welcome. My name is Chirag Dave. I'm a senior database specialist solution architect here at AWS. And I'm here to talk to you about minimal downtime major version upgrade strategy for Amazon RDS and Amazon Aurora Postgres. So agenda for today, I'm going to talk about what is major and minor version upgrade when it comes to Postgres. I'll talk about how do you perform major and minor version upgrade in RDS or Aurora Postgres. And more importantly, I'll be spending time on demonstrating and talking about use of logical replication for major version upgrade, or rather minimal downtime major version upgrade. So let's talk about what is major and minor version upgrade. So minor version upgrade in Postgres are typically contains security fixes and bug fixes. They do not contain any new feature, and generally they are patches to the binary. And more importantly, they are compatible with the earlier or later minor version of the same major version. So for example, if you're running on 10.12, for example, 10.13 will be, the next available minor version, it'll be compatible with 10.12 and any newer minor version that comes for version 10. Major version, in contrast, introduce new functionality and feature. And we typically track the Postgres community, which they release major version every year. And typically major version do require some system catalog and the page format do change. So it requires a significant amount of testing and planning around it because of the functionality, feature, and the structure of the data is changing. And the time requires to upgrade is even takes longer than the minor version upgrade. So let's talk about how the minor version upgrade works in RDS, and then we'll talk about major version. So minor version upgrade in Postgres typically means changing the binary of the Postgres database. So we shut down the instance, we replace the binary, and we restart the database. So generally the time it takes for minor version upgrade is typically less than 5 or 10 minutes. And as long as you don't have any long running transaction, typically the process is really fast. So you can reduce the time to do a minor version upgrade as long as you're not running any long running transaction during the minor version upgrade window. And in RDS, you can perform minor version upgrade either automatically or manually. So we have a feature called auto minor version upgrade, which is default on. And at this point, if it's on, we will upgrade your Postgres to a newer minor version upgrade when it's available during the next available maintenance window. Major version upgrade in Postgres, there are a few options. So first option is, yes, we have an automated in-place upgrade available to you. So we call it using modified DB instance. So you can either use CLI or console with a click of a button. We will upgrade your database from, let's say, version 10 to 12. Or going from one version to another version. So behind the scene, we use PG upgrade as a utility, and we'll upgrade your database. So it's all managed for you at the click of a button or the CLI. However, it does take time. Time to upgrade depends on how many objects. It's not depending on how large is your database. It really depends on how many objects you have. Typically, what happens behind the scene is we're changing the catalog. So more objects you have, more work to do, and more time it takes to upgrade. And during the upgrade, you're not able to connect to the database, so it's a downtime for you. And it could be a few minutes to several minutes. The second option that you have is the database migration service, where you can read data from a version 10 and then you can replicate it to another version of Postgres. So that's the option available to you, which allows you a minimal downtime upgrade. However, it does add up more complexity in terms of adding more service and the cost associated with it. You can always use PG dump and restore, which are Postgres native tool. And as long as you have a capability of taking a downtime, this is a perfectly good use of PG dump and restore for a tiny database. However, there's another fourth option is a logical replication, which I'm going to talk about more, and which allows you to do a minimal downtime upgrade. So what is logical replication real quick? Logical replication is a method of replicating data object and their changes based upon their replication identity, usually primary key or some sort of a unique key. So what's happening is you write or things gets committed to your primary instance, it's get written to your transaction log, and it translate back into a logical change. So anything gets written to a wall file, we translate into logical change, typically the old and new value, and that's the change we apply to the subscriber node. And because of that change, the way it's happening, we can replicate data between two Postgres major versions. Inside, there is a wall sender process that starts logical decoding of your write-head log and loads the standard logical decoding plugin, which is PG output. And we do support other decoders like PG logical, wall to JSON, and test decoding. So here's a quick diagram. Your wall file, wall sender is starting a logical decoding using PG output as one of the decoding plugin. All your wall changes, the old and new value, logically decoded value will get applied to your logical replica, we call it. So on the left side, it could be version 10. On the right side, it could be version 12, 13, or any other version. When it comes to logical replication, you have two options. You have native logical replication and PG logical. PG logical is an extension to Postgres, while native is part of the core. So what is the difference? Really, the difference is the functionality, right? So it's PG logical has some more enhanced functionality compared to native logical replication. However, for upgrade, it's perfectly fine to use native logical replication as long as you're moving from version 10 and above. And we support both. And in this video, I'm going to be doing a demo showing you how to use native logical replication for upgrade. So yeah, let's talk about my demo here. The setup is going to be, I have Postgres version 10 and 13 created. And then the first part is I'll be loading some of the schema and data. Then I'll be dumping the global objects and the schema from my source and loading it to version 13. That's my destination. And then I'll be using a publication and subscription. And I'll talk more about it during the demo. So let's go and jump to the demo here. I went ahead and created two Postgres cluster, one on Postgres 10 and one on Postgres 13. Let's make sure that this cluster is up and running. So I'm running this little script, which is going to show me the cluster status. And you can see here that I'm running CLI RDS describe DB instance for my identifier myPG10 and myPG13 respectively, and I can see my cluster is up and running. The next thing I will do is I will create certain roles. I will create a database and I will create certain roles, which is nothing but a user in Postgres to mimic something which is similar to your production instance. So I'm going to go ahead and run this script, which is creating my database, as I said, and I'm creating a couple of roles and a couple of users here. So I'm going to go ahead and run that. And this is I'm running to set up my source or my Postgres 10. So I'm running this on my Postgres 10 instance. As you can see, the server instance is 10.16, and I've created a database and few roles to mimic what you have probably in your production. The next thing I'm doing is I have to load some data. So for that, I will create some tables and load data. And for that, I'm using a PG bench script, which is going to be initializing it. PG bench is a generic Postgres benchmarking tool, which is going to create a few tables and insert some records in it. So in this case, I'm creating a PG dump and inserting about 1 million record. So now I have a table, 4 tables, and the accounts table will have about 1 million records. And that's the data that I'm going to be using to replicate. Now at this point, my source database, Postgres 10, has roles, has a database object, and has a data in it. Now the next step for the upgrade is to take the schema dump from Postgres 10 and load it to Postgres 13. So the next step is to dump schema from Postgres 10. So I'm going to be running this script. So notice here, the first thing I'm doing here is I'm using pg dump all with the -g. -g is a global object or global only object. And what this is going to do is it's going to dump all your global object, meaning all your roles and users and privileges, which are global for all your databases. So in Postgres, you can have n number of databases, but all your roles and users, they are common across all of your databases. So I'm dumping all my global object first. Another option is the no role password. That's something you need to pass because in RDS, we cannot see your password. So if you try to dump pg dump all without this option, you might get some error messages. So this will avoid dumping any password. So this is how we're going to get global.sql. And then the next thing I'm doing is I'm doing my schema dump for my database. My database name is my database. And for that database, I'm doing the schema only dump, which is just the data definition language. And what I'm doing it is I'm dividing into two different parts. I'm doing the pre-data and the post-data. This is an option available for pgdump. Pre is going to give you a schema with just the table definition, no index, no referential integrity. And the post will have everything related to your index and referential integrity. So when you load these files into your Postgres 13, you want to do the global first and then the pre-schema first. And then once your initial copy is done, then we'll run the post schema. And the reason behind it is when you do initial copy, which is a large chunk of data, you don't want to do it on your index table or the table with all the referential integrity. So now that I have dumped the data from Postgres or dumped the schema from Postgres 10, I'll be loading it on my Postgres 13. So let's go ahead and do that. So I'm just loading schema. So first part will be loading the global object followed by pre-schema. So you might see some error. That's something you can safely ignore because you are trying to alter some of the RDS admin, which is not allowed, but that's safe to ignore. But you can see that when I apply the schema changes, I can see on my pgbench account, branches, and history table it's been replicated. It's been copied. So now my Postgres 13 has the exact same schema as my Postgres 10, but no data. Let's verify what I have. So I have another script that I can run, which can show me the count in both my databases. So let's verify that just real quick. So as you can see in my Postgres 10, I have 4 tables with million record, 10, 0, and 100 respectively for account, branches, history, and teller. And in Postgres 13, the data is not there, but I do have a schema. That's what I did. Publication and subscription. So for publication, I'll be publishing all my tables from my Postgres 10, and then I'm subscribing on my Postgres 13. So let's go ahead and create first the publication on my source, that is Postgres 10. And as you can see, I ran a simple command, create subscription, create publication called mypub for all tables. Again, you do have option if you want to selectively replicate only certain tables, you can certainly create publication and then you can provide a set of tables. Once the publication is created, we're going to go and create subscription on your subscribing side, which is your Postgres 13. So this is my Postgres 13. Let's make sure. And that's my Postgres 13. And this is the node where I'll be running subscription. So while the subscription is running, which I'm going to run this script here, which is showing me the output of PG replication slot. That's the view in the database which shows you if there is any slot, and there are none because there is no subscription at this point. And it shows you the status of your replication through another view called pgstat replication. Both are showing no data. Now I'm going to create a subscription. As soon as I create a subscription, you will see that the slot gets created and the replication will start to proceed, which is the initial copy of your data from Postgres 10 to 13. There you go. I created a subscription and I gave a name to a subscription, and you pass an argument about your connection string. And the part of the subscription creation is it creates the slot. Right here you can see a slot getting created and you see the initial sync is happening. And at some point the initial sync is done. You see that initial sync was running, and at this point the initial sync is done, and now the regular CDC is proceeding at this point. Now let's go and verify that the data got copied to my Postgres 10 or not. Right, so I'm going to run this script again, which shows me the count in both the databases, and yes, I do. All my million records in pgbench account got copied, and the rest of the table as well. So that's exactly what I want. And now if I go to my Postgres 10, and if I want to verify one more time, I can certainly do that and have my data replicating. The next thing I want to show you is that how the CDC works. In order to do that, I am going to run another script which is going to do some more update and delete in my database. Again, I'm using pgbench, and pgbench is going to load some more data. So let's go and verify that. But before we do that, we need to make sure that we apply that post schema we were talking about. So after the initial copy is done, we want to create all the primary key and indexes on those. So it's very important that you run that step, which is going to create the post schema. So I'm going to run that as well. So this is going to connect to my Postgres 13 and create all the remaining indexes on those tables. So as you can see, it's altering my accounts, branches, and teller, and it's creating a primary key. If you have any referential integrity, it'll create at this step. So this is part of my initial schema dump, which was the post-schema.sql. Now that's done, I'm going to go ahead and load some more pgbench workload here. So this is just doing some pgbench benchmarking, which is updating a record. And one of the things it does, it updates or insert record in the history table. Now let's go and verify that my data got replicated. And you can see here that my data is replicated. Now the history table did not add any record. Now the 5000 record got replicated. Perfect. However, there's one key thing that you need to be aware of. In the history table, I do not have any primary key. So if I describe my history table, it does not have any primary key. That's the default. And when that's the case, you can replicate the inserts, but you cannot replicate any update or delete. So that's an important consideration you have to make when you are replicating logically. So let's go and try and do this. I'm going to connect to my Postgres 10, and I'm going to try and update my history table and set one of the column called mtime, for example. It's a date timestamp field. So I'm just going to say set it to now for all rows. And I get the error message saying you cannot update because it is part of the replication, logical replication. It does not have replica identity. So in order for this table to get replicated for update and delete, you have to make sure that you set your replication identity to full. So this is one important step you need to do before you set your logical replication. Ensure that all the tables have the primary key. So now I'm going to alter this table and I'm going to set replica identity to full. I'll put some link in the slides here that will show you the description around what is replica identity full mean. Once the replica identity full is done, at this point, Postgres is going to capture all the changes for all the columns in this table. And now if I do an update, you can see that I don't get any error message and I'm able to replicate all the data. Let's verify the data got replicated. So if I do record for this, and if I run the same query on my Postgres 13, I would see the same timestamp which got replicated. So with this demo, you can see that some of the best practices to upgrade your Postgres 10 to Postgres 13 with a minimal downtime with logical replication. Now that both the data are in sync, at any given time, you can shut your application which is connecting to Postgres 10 and move your application to Postgres 13, and you can upgrade your database to Postgres 13 essentially with a minimal downtime. One of the most important steps of your upgrade process is to promote or make your Postgres 13 as a standalone node. Remember, at this point, you're still replicating from Postgres 10 to 13, and that is done using a replication slot. So as you can see here, my replication slot is still active, that is replicating from 10 to 13. So what you want to do is you want to remove this replication slot. And one of the easiest way you can do that is just simply by dropping a subscription that we created earlier. Upon deleting or dropping the subscription, we're essentially dropping a slot from which is created on Postgres 10 and will enable your Postgres 13 to become a standalone node. So at this point, as you can see here, my replication slot is dropped. At this point, you can decommission your Postgres 10 and start using your Postgres 13. Well, that concludes my talk. I've demonstrated use of logical replication for a major version upgrade with a minimal downtime. One last thing I would like to mention that if you're on version 9.6, for example, and if you like to use logical replication, PG Logical is another option for you. and you can use PG Logical just as I've shown with the native logical application to upgrade from 9.6 to, let's say, version 10 and above. Thank you again for watching, and have a great day.